So right now, I'm going to count to 5. 1, 2, 3, 4, 5. Pretty simple, right? But now I'm going to try and count 5 seconds. 1, 2, 3, 4, 5. Now, what's wrong with counting 5 seconds, or counting to 5, more specifically? Well, when you're counting to 5, there's always going to be an uneven gap in between consecutive numbers. Let me prove it to you. So, the gaps in between these numbers are basically whole numbers, but in between seconds, we have deciseconds, or tenths of a second, and we also have centiseconds, which are hundredths of a second, and milliseconds, which are thousandths of a second. So if you're counting to 5, and you're trying to count 5 seconds, then you could be like 2 milliseconds off for each number. So, like, for example, maybe 1 does not last 1 second. Maybe it lasts 0.997 seconds. And maybe 2 lasts a total of 1.001 seconds. And then when you get to 3, you say 3 for 0.998 seconds, maybe. Or maybe 4 goes in at exactly 1 second, coincidentally. And then when you finally hit 5, maybe it's around 0.995 seconds. So as you can see, these don't quite arrive at 1 second, except for this one. So there is an uneven space in between consecutive numbers when you're trying to count 5 seconds. So it may not exactly be 5 seconds. So when you try to count 1 second, you may be like a couple milliseconds off. But say you actually did do it perfectly, and you managed to count 1,000 milliseconds for every number. Well, we move on to microseconds next, which are millionths of a second. Now, normally your clocks or stopwatches can't measure microseconds, but they can still be imagined because, like say you're counting to 5 and you're counting 5 seconds. Maybe 1 lasts a total of 1.000002 seconds. So it's not exactly 1 second. It's actually 2 millionths of a second off. So it's 2 millionths of a second longer than 1 second. Some of these might also be off as well. And because there's an infinite number of decimal digits you can add to this, and an infinite number of units of time, then maybe 1 could potentially last 1.00000000000000000000004 seconds. If it lasts this long, you can see like it's literally like 4 bajillionths of a second off. So it's still not quite at 1 second. So so things are not always exact. So you can't exactly count to 5. You can't, like, counting to 5 is literally not possible. Counting to 5 unevenly, however, is possible, but if you're trying to do it perfectly, then that would be impossible. So does that mean that 1 is actually a number, or have I been fooled this whole time and it's just 1.00000000000, and at some point it just hits 3 or 5? Could be something like that. So that means that means when it hits exactly 1.000000000 and so on seconds, then that is going to last literally 0 seconds. Like that's literally there's literally no time for that to happen. So it's quite literally impossible to count evenly to 5 because the time it takes for you to say a number will not always be exactly 1 second. It will always be some crazy looking place off. Like, even if you try to add as many digits as you can to the decimal, it will still not exactly equal 1. It may be some other place off. And normally, people can't exactly count to 1.000000006 seconds. Like, that's quite obvious, but if you did, then you'd still not quite arrive at 1 second. That's what I'm trying to say. This kind of reminds me of how if you divide the distance between 2 points, like 1 and 2, let's say, like there's obviously a length of 1 between these 2 units, right? Well, we can divide this in half to make 0.5 be the midpoint, and then between these 2 lines you have 0.25. And this one measures 0.75. But then divide this in half, you get 0.125. And then divide this in half, you have 0.0625. And divide that further, you get 0.03125. And further, you get 0.015625. And this goes on forever. So you can constantly split this in half, and you'll have an infinite number of numbers that can fit in this small space. So the distance between 1 and 2 is infinite. So maybe 1 must equal infinity. What do you guys think? Anyway, guys, that's my explanation of how getting exactly 1 is not possible if you're trying to measure time or something like that. So go ahead and try and count to 5, and you'll likely be a couple octillionths of a decimal place off if you're trying to count as perfectly as possible.